Good day, young engineers. Welcome for another topic, which is synchronous generator.
So the first problem in Unit 3 is, in some places it is necessary to supply 300 kilowatt of 60 Hz power. The only power sources available operate at 50 Hz. It is being decided to generate power by motor generator set. The question is, by how many poles should the machine have in order to convert from 50 Hz power to 60 Hz power? So we have the given frequency 1 and 2, which is 50 Hz and 60 Hz respectively. So we have to find how many poles should the machine have in order to convert 50 Hz to 60 Hz power. By solution, where the speed of a synchronous machine is related to its frequency by the equation 120 frequency over pole. To make a 50 Hz and a 60 Hz machine have the same mechanical speed so that they can be coupled together, we see that in sync is equals to 120 times 50 Hz over P1 or pole 1 equate to 120 times 60 horsepower in frequency 2 over the pole 2. So it will result to pole 2 over pole 1, which is equals to 6 over 5 or 12 over 10. Therefore, a 10-pole synchronous motor must be coupled to a 12-pole synchronous generator to accomplish this frequency conversion. So the next problem, we have the given voltage, which is 480 volts, current 1 and 2. In current 1, it is 400 ampere at 0.9 power factor lagging, and in current 2, it is 300 ampere at 0.72 power factor lagging. We will instruct to find the following. A, which is the real and reactive power supplied by each generator to the load. B, overall power factor of the load. And C, what direction must the field current on each generator be adjusted in order for them to operate at the same power factor. So, first solution in A, P1 is equals to square root of 3 times the voltage, current, and power factor. So, just simply input the following values. It is equals to square root of 3 times 480 volts times 400 ampere and power factor of 0.9. It will result to 299.30 kilowatts. Next is the reactive power in 1. It is equals to square root of 3 voltage times the current times sine theta. To get the theta, it is equals to cosine inverse of 0.9, which is equals to 25.84. So input square root of 3 times 480 volts times 400 ampere sine of 25.84, it will result to 144.95 kilovar. In P2, it is the same in P1, which is equals to square root of 3 times the voltage, current, and power factor. Which is equal to square root of 3 times 480 volts times 300 ampere at current 2 and 0.72 power factor. it was equals to 179.58 kilowatts. And in Q2, it is equals to square root of 3 VT, or the voltage, current, and sine theta. So theta is same calculation in Q1. It is equals to cosine inverse of 0.72 power factor, which is result to 43.95. So input the values. It is equals to square root of 3 times 480 volts times 300 ampere sine of 43.95 is equals to 173.10 kVAR. So after we get the real and reactive power supplied by its generator to the load, we then therefore can solve the overall power factor that can be found from the total real and reactive power supplied to the load. So in B, we just simply solve the power total and Q total of the said power. So P total is equals to P1 plus P2, which is equals to 478.88 kilowatts, Q total is equals to Q1 plus Q2. Just simply add the 2. It will result to 318.05 kVAR. So the overall power is given in the equation power factor is equals to cosine theta, where cosine theta is equals to tangent inverse of Q total over P total, or tangent inverse is equals or tangent inverse times 318.05 of Q total and 478.88 of P total, which is equals to overall power factor of 0.833 lagging. So in C, what mass direction of the field current? So field current in generator 1 should increase and field current in generator 2 should be simultaneously decrease. Thank you.